So in this particular problem, we're going to see that ammonia, which acts as a base, is being drawn through a solution containing HCl. So what we're going to do is we have so much HCl, which is listed in the question at 100 milliliters of 0.015 molar HCl. So we're going to see how much of that ammonia neutralizes the HCl. But then basically we're going to back titrate what we know hasn't been reacted using NaOH. So we're going to start with the second thing and find out how many moles of NaOH we actually need. We have 13.1 mils of 0.0588 molar NaOH. So our first step here is just to try and figure out how many moles of NaOH are used to neutralize the excess HCl, the stuff the ammonia didn't actually react with at all. So we do that out and we find that it's 7.703 times 10 to the negative 4 moles of NaOH used, which since it's a 1-to-1 ratio, NaOH plus HCl, we find that that should be the excess number of moles of HCl that haven't reacted with ammonia. So to find the initial number of moles of HCl, we simply use the 100 mils times 0.0105 molar HCl. So we plug that into the calculator, even though it's a fairly easy calculation, and we end up with 0.00105 molar HCl to start with. So we started with 0.00105 molar HCl, moles, and we're going to subtract away what was left we found in our back titration part. So this is just a simple subtraction step where we're going to take the amount of moles initially, and then we're going to subtract away what we found to be left over, the stuff the ammonia did not neutralize as it was pulled through solution. And we're going to deal with what that ammonia did in part B. So 2.80 times 10 to the negative 4 moles of NaOH should have been what was present. Since we're doing a parts per million, we're actually going to turn this initially into grams. But in part B, we're automatically going to have to go to the number of molecules to do our proper parts per million. So 2.8 times 10 to the negative 4 moles of ammonia times the molar mass of nitrogen, which is 14 grams for the nitrogen, and then 3 grams for the hydrogen, so 17 grams per mole. Giving us 0.00476 grams of ammonia that can be accounted for, which completes part A. So in part B, it says how many parts per million of ammonia were in the air. Air has a density of 1.2 grams per liter, and the average molar mass of air, remembering it is a mixture, is 29 grams per mole. So the first thing we do is we convert the grams of ammonia into molecules of ammonia using Avogadro's number. And we end up with what we expect to be a big number, and 1.686 times 10 to the 20 molecules of ammonia are present. So that part's already done for us. We need to figure out exactly how many moles of air are pulled through this solution. So we have the fact that there is 10 minutes at 10 liters per minute. So let's figure out how many liters of air were pulled through the solution. So 10 liters per minute times 10 minutes. Hopefully we don't need a calculator for this, but we're just going to keep it going. So 1.20 grams for every liter of air. And now we can actually figure out the number of moles of air because we have an average mass. Remembering, once again, air is a mixture of nitrogen, oxygen, and some other traces. So fire that into the calculator. Move the page up here for a second. We end up with 6.02 times 10 to the 23 molecules. So we're going to turn the number of moles of air into the number of molecules of air. We're just going to do it all in one step. Firing it into the calculator, we end up with 2.5 times 10 to the 24 molecules of air is the estimation at 10 liters a minute times 10 minutes. So we're just going to do our parts per million calculation, and if we don't remember, it's the number of molecules that I'm just going to make a mistake here on this recording, but anyway, it's the number of molecules that we have of interest, which is the molecules of NH3, and we divide that by the total number of molecules of air, which we just figured out. So 1.686 times 10 to the 20 divided by 2.5 times 10 to the 24. And then we multiply that whole thing to 10 to the 6, just like doing a percentage. And our answer that we get, just so I divide off, so the left and right are separate, the parts per million is 68 ppm. And we can read in the initial part of the question that the upper limit is 50 parts per million. And we've now determined that the amount of ammonia present is 68 parts per million. So that takes us down to part C. So part C says, is the manufacturer in compliance with regulations? And no, they're over. 68 parts per million is greater than 50 parts per million, and we'll give it a little mad face there to end.